I'm Greg Tremelling with NEC Energy Solutions, and I'm going to show you an experiment here on what happens when you accidentally short lead-acid batteries.
These are brand new, fully charged 35 amp hour lead-acid batteries. The energy from these arc events are actually welding the cables together, making it difficult to pull them apart. If the cables were to remain welded, further propagation of this failure is likely, including melted wires, flames, and potentially a rapid disassembly of the lead-acid battery.
As you can see in that last experiment, there's missing pieces of metal and melted copper that sprayed as part of the arc flash event. This snapshot illustrates the arc energy and potential danger of accidentally shorting a lead-acid battery, and why you should be interested in learning about a lithium battery from NEC Energy Solutions, which protects you from this risk. We'll connect it, and then we'll take the ends, and that's it. And you can leave this shorted indefinitely. And you can see it goes to 0 and then recovers. And I can keep this going. The ticking sound that can be heard in the background is the battery retesting its environment by trying to determine if it's able to reconnect to a normal load. The product has been designed to support that. And the beauty of the system is that you can't do this with lead. This is safety. The next section of this video will use a high power load to highlight key differences between NEC Energy's lithium-ion battery and what you would see if you bought a lead-acid battery of the same size. Altogether, this is the equivalent of 25 cars with their high beams. Turn on one bank of lights, 7 cars, another bank of lights, 7 more cars, light, 25 cars total. As you can see, the light has become very dull. A close-up of the voltmeter shows that the lead-acid battery terminal voltage dropped to less than 8 volts. So now we have the lithium battery hooked up, and we're going to apply the load and watch the meters and see what happens. So we're going to put on the 2 large load banks and then add all of the other switches like we did before. Notice that when using the NEC Energy Solutions lithium battery, the lights are still very bright and have no perceivable drop in light output. And the battery is maintaining 11.6 volts. When the load on the battery starts to exceed the high power ratings of the battery will start attempting to drop the load. After dropping the load, it will automatically reconnect to see if the load has been reduced to acceptable levels. As the load is reduced to within the 6C 210 amp level, the battery returns to normal operation. Maintaining 209 amps at 11.7 volts. And I can short this any way I want. And when I remove the short, the load returns. In addition to the safety features you just saw in this video, NEC Energy Solutions lead-acid replacement products also have redundant overvoltage protection, redundant undervoltage protection, redundant over temperature protection, and are UL 1973 compliant. This lineup of lead-acid replacement products offers the power, safety, and long life required by today's applications.